Welcome to College Algebra Videos. Today we'll be using the properties of logarithms again. This is the second video. In fact, today what we'll do is use the properties of logarithms to write logarithmic expressions as one algorithm. So we'll be taking complicated logarithmic expressions and somehow be able to write it as one. The key to these are these properties of logarithms. So if you haven't done so yet, please pause the video right now and copy these down, unless you already have them somewhere. In that case, then just go ahead and find the sheet that has these properties. Okay, so the idea is that we're going to do the following. We're going to get an expression that maybe is an addition of logs, or maybe there's a subtraction of logs, or maybe there's a number in front of a log. And the idea is that we're going to use these properties to go backwards, to kind of write it as one expression. What I want to emphasize here, what's really, really important, is especially for property 1 and for property 3. The symbol that I'm using, the plus, is in between the logs. You see, log, log, it's in between the logs. And the minus sign is in between the logs. Sometimes people think, well, there are mistakes people make usually, but this is critical. This is something you might want to write down. The plus and the minus have to be in between two different logs. Okay, so let's go ahead and try this one. Here's our first example, and here is what I wanted you to notice. I wanted you to see that there's a plus sign that goes in between two different logs. So what this means is that we can write this as one logarithmic expression. And in fact, the property says, and I'm going to write it down just for reference, it says that if you have the log base a of m plus another log of a base n, then we can write it as one log in the same base, and then we take the m and the n and we multiply them, m times n. So in this problem, our m is like the x plus 1, our n is like the x minus 1. And so what we are allowed to do is the following. Our answer would be is that I can have, this would be equal to the log. The base is 10, but we're not going to write it down. And then what I do is I take the x plus 1 and multiply it times the x minus 1. Now usually you can leave your answer like this, but today it's okay to simplify. This is log. You guys know how to multiply this out. It's x squared minus x plus x minus 1. And so after you simplify this, you get that this is the log of x squared minus 1. And that would be the answer. So you see, we took a sum of two logarithms and wrote it as a single logarithm. So that's the goal for today. So let's look at another example. Now there's a couple things going on here. We have a difference, but it's not a difference of logs yet because there's this 1/2 in the way. And so here's where we use this property. I'm going to write it over here. Remember that there is a property that says that if there's a number outside of the log, then we can write that number in the front on the left of the log. It's the power of the number inside of the log. So it would look like that. So I'm going to start off with that. So this is log 2 of x plus 1 minus log 2 of x minus 1 to the 1/2 power. Okay, hopefully you remember. And so, I mean, this is going to require us to remember many, many, many properties. But hopefully you remember that anytime you have a number to the 1/2 power, it really means the square root of that number. And so we can simplify this just a little bit further. So this is the log 2 of x plus 1 minus the log 2 of the square root of x minus 1. Okay, so it looks a little bit nicer. So now let's go ahead. Now I see a difference of two logs. I saw it up here too in the first one, but I wanted to wait. I wanted to change this 1/2 to a square root first. But now I see a difference of two logs, and now I want you to recall the following. We have that if I have a log, doesn't matter the base, m, minus the log of some other number, then once you have this difference, we can write this as one log, and we take the number that's this one right here, this m, this is the numerator, and the n is the denominator. So what makes this the denominator is actually the minus sign. And so again, we have to remember that one. And so in this case, that means that our base is 2, so log base 2. Our numerator is the x plus 1. Our denominator is the square root of x minus 1. And so this is our answer. So we were able to take a logarithm with many different symbols, but two different logarithms right here. So we were able to take a difference of expressions that have logarithms, and somehow, or not somehow, but with the properties of logarithms, we were able to combine it into one. And so that's the goal for our homework today. And so let's have you try. Here's one. Maybe pause the video right now and see how it goes, and I'll have the answer after you unpause it. Okay, this was a little bit more complicated, and there's a couple of ways to do this, but I think that the easiest way might be to do what sort of follow the order of operations. Okay, remember, this is one way. There are more than one way, so if you have a different way and you want to show it to me, feel free to show me during class. I would probably take these two and combine them. I know that if I have the log, actually, sorry about this, but I want to use my reminders in red. I know that if I have the log of a number plus the log of another number, regardless of the base, I can go ahead and multiply the two numbers, m and n. So that's what I'm going to use here. ln is just another type of log. There's a plus sign right here in the middle. So I'm going to go ahead and say, well, this is really 2 natural log of p minus 4 natural log of 2 times q. Okay, and in fact, we could put parentheses on the 2, or on the 2 and the q. So 2 times q, like that. Okay, by the way, you're allowed to skip steps. So again, as usual, I will show as many steps as possible. Here, now what I notice is that I have the following. Let me rewrite this, 2 natural log of p minus 4 natural log of of 2 times q. Or of 2q if you'd like. So now I have to bring these, I have these numbers in front, and these become powers. And so the one I'm thinking about is the following. If you have a number in front of a log, or to the left of a log, then we are allowed to bring it in as a power of the number inside of the log. Okay, so that's the rule I'm using. And so in this case, I have natural log of p squared because this number becomes the power. And then here, I get natural log of 2q to the 4th, because this number in the front becomes the power up here. And now I'm going to simplify a little bit more. So let me scroll up. So this is still natural log of p squared. But here I have the natural log of 2 to the 4th and q to the 4th. Hopefully you remember all your rules of exponents. We know that this 4, we're saying that we're multiplying 2q times itself 4 times. So it's 2q times 2q times 2q times 2q. But that means there's 4 2's and there's 4 q's. Again, commutative property of multiplication. And so if I simplify this just a little bit more, I get natural log of p squared minus the natural log. 2 to the 4th is 16, q to the 4th. And now I go ahead and use the last one. So I use the fact that the third property, that if I have the log of a number minus the log of another number, regardless of the base, it's the log of the first number, m, divided by the second number, n. And that's what I have here. I have a subtraction of two logs. And so I'm going to go ahead and say, well, this is the natural log of the first number, which is p squared, minus the second number, which is 16q to the 4th. And sure enough, this is the correct answer. So hopefully this helps. Good luck with your homework.